Good morning, friends. I am here again for my course, Aircraft Systems. Today I am in lecture number 33, that is Fuel Inerting System. I am Dr. Y.D. Dwivedi, Professor from Institute of Aeronautical Engineering, Hyderabad, India. In my today's topic, I have the Fuel Inerting System, Principles of Operations, Oil Tanker, Aircrafts, other modes, uses of inerting system, potential risk and health concern, fuel tank safety, maintenance program and practices, and possible problems areas. So what is the fuel inerting system? An inerting system decreases the probability of combustion of flammable material stored in a confined space. The most common such system is a fuel tank containing a combustible liquid such as gasoline, diesel fuel, aviation fuel, jet fuel or rocket propellant after being fully filled and during use. There is a space above the fuel called the ullage. Ullage or head space is the unfilled space in the container, particularly with liquid. So what is the ullage? Ullage, if you see, this is the tank here, and here is your filling point, and if you are filled up to here, this part, the part which is filled with air, this is called the ullage. This is called ullage. This space which I am making like this is the ullage or the head space in the unfilled space in a container, particularly with liquid, and here is your fuel. So that contains evaporated fuel mixed with air, which contains the oxygen necessary for combustion. Under the right condition, this mixture can ignite, and inerting system replaces the air with inert gas such as nitrogen, which cannot support the combustion. So in this inerting system, what we do, that in this space which is empty, in this space like this, just I will make some more bigger. So this is, here is the fuel, and in this empty place we put the nitrogen or some other inert gases so that the fire resistance capacity of the fuel will increase, because the fire will only take place whenever there is a oxygen or there is a fuel or there is a temperature. So we fill with some inert gases so that the fire chances are reduced. So principle of operation, we know that there are three elements required to initiate and sustain combustion in the ullage: and ignition source, that is three. If you see, there is it is called fire triangle. So first we need here heat in a one triangle, then we need here oxygen, O2, and then we need the fuel or any combustible material. So these things are required. So fuel and oxygen, first heat, then oxygen and the fuel. Combustion may be prevented by reducing any one of these three elements. In many cases, there is no ignition source, that is storage tank. If the presence of an ignition source cannot be prevented, as is the case with most tanks that feed fuel to internal combustion engine, then the tank may be made non-ignitable by filling the ullage with an inert gas as the fuel is consumed. At present, carbon dioxide or nitrogen, we are using either carbon dioxide or the nitrogen gas we are using almost exclusively, although some systems use nitrogen enriched air or used steam. Okay, so nitrogen enriched air, or sometimes we use the steam. So nitrogen enriched air means where oxygen quantity is reduced. So or we use some steam also, the hot steam we can use. Using these inert gases, that reduces the oxygen concentration of the ullage to below the combustion threshold. So for the combustion, we need a sufficient amount of oxygen. So if we can reduce this amount of oxygen, or in the air we increase the nitrogen in place of oxygen, if you give the more concentration of the nitrogen, then also we can stop the fire. Or we cannot, fuel will be there, and heat also we will try to reduce the heat. If the heat is more than the required, then there is a chances of fire to take place. We have the oil tankers. Oil tankers fill the empty space above the oil cargo with inert gas to prevent fire or explosion of hydrocarbon vapors. Oil vapors cannot burn in air with less than 11% oxygen content. So if the oxygen content is less than 11%, then it will be very difficult to get the fire. The inert gas may be supplied by cooling and scrubbing the flue gas produced by the ship's boiler. Where diesel engines are used, the exhaust gas may contain too much oxygen, so fuel burning inert gas generator may be installed. One-way valves are installed in process piping to the tanker spaces, prevent volatile hydrocarbon vapor or mist from entering other equipment. Inert gas systems have been required on oil tankers since the SOLAS regulation of 1974. The International Maritime Organization publishes technical standard of IMO 860 describing the requirement for inert gas system and other type of systems, and this is very compatible with the chemical use. Now for aircraft, we have to discuss for the aircraft. So aircraft tanks for combat aircraft have long been inerted as well as being self-sealing, but those for transport aircraft, both military and the civilian, have not, largely due to the cost and weight consideration. Early uses using nitrogen were on the Handley Page Halifax 3 and Halifax 8, Short Stirling and Avro Lincoln B-12, which incorporated inerting system from around 1944. These are the aircrafts like Handley Page, Halifax, Short Stirling and Avro Lincoln B-2. These were using the inert gases. Then we have used the Clive Kimmel first proposed an inerting system to passengers airline in the early 1960s. His proposed system for passenger aircraft would have used nitrogen. However, the FAA refused to consider Kimmel's system after the airline complained it was impractical. Indeed, early version of Kimmel's system weighted 2,000 pounds, which would have reduced their passenger capacity substantially. However, the FAA did not almost no research on this issue. Now, other methods of our inerting is two other methods in current use to inert fuel tank are the foam suppressant system and the ullage system. The FAA has decided that the added weight of an ullage system makes it impracticable for implementation in the aviation field. Some US military aircraft still use nitrogen-based foam inerting system, and some companies will ship container of fuel with an ullage system across rail transportation routes. Now, what is the fire retardant? What are the chemicals which are used to retard the propagation of the fire? A fire retardant is a substance that is used to slow down or stop the spread of fire or reduce its intensity. This is commonly accomplished by chemical reaction that reduce the flammability of fuel or delay their combustion. Fire retardant may also cool the fuel through the physical action or endothermic chemical reaction. Fire retardant are available as a power to be mixed with water as firefighting foam and fire retardant gels. Fire retardants are also available as coating or spray to be supplied to an object. So these firefighting foams or fire retarding gels, these are used to retard the fire. The spread of the fire can be reduced. The intensity of the fire can be reduced by using such type of firefighting foams. If you see your fire extinguishers, the yellow color or the amber color, they are triple C, firefighting foam. In that 9 liter or 20 liter firefightings are foam, a chemical is put inside. This chemical is trying to either reduce the oxygen or trying to cover and it gives the cooling effect. So heat will be reduced. Principles of operation of this inert system is, in general, fire retardant reduce the flammability of material by either blocking the fire physically or by initiating a chemical reaction that stops the fire. Physical action, there are several ways in which the combustion process can be retarded by physical action. So by cooling, or this you can cool. I have shown, this is the triangle, fire triangle. So there is a heat, then there is oxygen, and then there is a fuel. So if you reduce this heat, means you are cooling. So first is the cooling. So by cooling, some chemical reaction actually cools the material down. So whatever foam we are using, if this is the temperature is 500 degrees centigrade, it will try to reduce to 400 degrees centigrade. So it will retard by forming a protective layer that prevents the underlying material from igniting. So if this is the material, so here one layer will be formed. This layer will allow that oxygen in this area is reduced. So your propagation of the flame will be reduced. By dilution, some retardant release water and or carbon dioxide while burning. This may dilute the radicals in the flame enough for it. So another is the dilution. Some chemicals are there. After burning, they will evaporate the water, and this water or the carbon dioxide, water and carbon dioxide both are very good retardant, and they will try to retard the acceleration of the fire. Now next is the chemical action. Reaction in the gas phase, chemical reaction in the flame, that is the gas phase, can be interrupted by fire retardant. Generally these retardants are organic, halides, halokins such as halon or Phos-X. The chemical used in these types of retardants are often toxic. Reaction in the solid phase, some retardant break down polymer so they melt and flow away from the flame. Although this allows some material to pass certain flammability test, it is not known whether fire safety is truly improved by the production of flammable plastic droplets. So in this, what we are putting some materials like halon and Phos-X. These halon and Phos-X will try to, they are the polymer, but they also burn, but the rate of burning is reduced as they melt and flow away from the flame. Although this allows some material to pass certain flammability test, it is not known. And the fire, so production of flammability and the plastic droplets are generated. Next is this is the char formation, charcoal. For carbon based fuel, solid phase flame retardant cause a layer of carbonaceous car to form on the fuel surface. This char layer is much hardened to burn and prevent further burning. So some charcoal like black color, a very hard thing is formed on the surface, and it will try to extinguish the fire. Then intumescence, these types of retardant materials incorporate the chemical swelling behind the protective car layer, providing much better insulation. They are available as a plastic additive and the paints for protecting wooden building or steel structures. Now, what are the uses of this material or the retardant? So, fire extinguishers. We use such type of material in fire extinguishers. I have shown here a portable fire extinguisher. It is in the red in color, and here we have different types of handles and all. Next is a fire coating, then forest firefighting, aerial firefighting, and the textile. So these are the uses where we use this type of material. Fire extinguishers, here I am showing a class A fire. It is called a foam, is used as a fire retardant in 2.5 gallon APW and CAFS extinguisher to contain incipient brush fire and grass fires by creating fire break. It is a 2.5 gallon or nearly 9 liters in this foam is there. So it will try to reduce a small fire, bush fire or grass fire. It can be prevented. Other chemical retardant are capable of rendering class A material and class B fuel non-flammable and extinguishing class A, class B and some class D fires. So class A, class B and class D. These are the three types of fire. This type of extinguisher can extinguish by the foam. The class A is simple as your bushes, your leaf and all. Class B is oil fire and all. So like this it is divided. Fire retardant slurries dropped from aircraft are normally applied ahead of the wildfire to prevent ignition, while fire suppression agents are used to extinguish the fire. So here the surface coating, we have to give some surface coating. Object may be coated with fire retardant. For example, Christmas trees are sprayed with retardant. As a tree dries out, it becomes very flammable and a fire hazard. Steel structures have a fire retardant coating around column and beam to prevent structural element from weakening during a fire. Next is forest fire fighting. How we do the forest fire fighting? Early fire retardants were mixture of water and the thickening agent, and later included borates and ammonium phosphate. Generally, fire retardants are dropped from aircraft or applied by the ground crew around a wildfire edges in an effort to contain its spread. This allows ground crew time to work to extinguish the fire. However, when needed, retardant can also be dropped directly onto the flame to cool the fire and reduce the flame length. Now, aerial firefighter means from the air. How we can do? Aerial firefighting is a method to combat wildfire using aircraft. This type of aircraft used include fixed wing aircraft and helicopters, smoke jumpers and repellers. And repellers are also classified as aerial firefighting, being delivered by parachute from a variety of fixed wing aircraft or rappelling from helicopter. Chemicals used to fight fires may include water enhancer or specially formulated fire retardant. So this aerial fire fighting can be done by the fixed wing aircraft or by the rotary wing like helicopters and all. They carry the smoke jumpers or some things. They can also carry the water enhancer and especially formulated some type of chemicals like foams and all. They are carried in the aircraft and they are spread in the very high pressure. So this is a very huge area is covered by the particular aircraft. This you can see here. One diagram is here of DC-10 tanker operated by a private contractor for the US Forest Service demonstration. A water drop during thunder over the Empire Air Fest at March Air Rescue Base in 2012. So this is shown here, a simple demonstration of the firefighting, how the water is sprayed and how much area it is covering. Images of aerial firefighting, I can show you here that this is the parachute here. This parachute is used, it is containing the water or some chemical, and it is flown. US airmen with 129th Rescue Wing, California Air National Guard drop water on the rim fire near Yosemite, CA, August 2013. If you see here, Command K-1200 used for the aerial firefighting in. Okay, so this is another one. Here is a Kern County, California Fire Department Bell 205 dropping water during a training exercise at the Mojave Spaceport. Here this you can see Los Angeles County Fire Department Sikorsky S-70C Firehawk during a water drop demonstration at Station 129 in Lancaster, California. So these are the few things which I have shown here, and this I have taken from this website. It is not mine. So this is the source of this information. Now water bombers. You might have seen the bombers and the putting bullets and ammunition, arms and all. But for a high and jungle fire where a lot of area we have to cover, that time we have to use the water bomber. These are the few aircrafts. They carry a huge amount of water. So a consolidated PBY Catalina amphibious flying boat air tanker. It is a flying boat air tanker. Lot of water it will carry and it will spray. And Italian Canadair CL415 at work. So how it was, it is throwing. And next is the PJLM-18 Drombander drop water near Mobile, South Dakota in the US. So these are the few images which is showing that how the aircraft are used for the firefighting of the area. Now potential risk and the health concern, because if we use this inert system, this is not good for health. The human being who are working nearby, they may get the injuries or they may get some serious problems. So most chemical fire retardants are organic halides, halocans such as halon and phosphorus, which are proven to be toxic. During 1980, the most commonly used fire retardant material was pentabromo-diphenyl ether. It was banned by the government due to its potential health and environmental concern. It was then replaced by chlorinated tris, chloroalkyl phosphates, halogenated aryl ester, and tetrabromophosphate diester, which later were proven by an EPA study that they contained mutagens that could be absorbed into children's body. Okay, so now study has shown that a small percentage of population may have allergy towards the chemical substance used as a fire retardant. Studies also have shown that a drop of retardant chemical directly into a stream may cause sufficient ammonia concentration in the water, which is lethal to fish and other aquatic organisms. If the amount is large enough, it is likely that it will lead to a lethal consequences towards human. So this ammonia and these all things which we are using, this may be very dangerous for some of the people. It may be very allergic. So we have to make sure that people should not get suffered. So health concern I am talking here. Long-term exposure to these chemicals are likely to develop cancer or for firefighters, and the potential contamination towards the environment will be another safety concern. Many of these chemicals are now recognized as a global contaminants and are associated with adverse health effects in animal and human, including endocrine and thyroid disruption, immunotoxicity, reproductive toxicity, cancer and adverse effect on fetal and child development and neurologic function. One of the most common way to spread the retardant is through aerial firefighting, which means that there are chances that these toxic chemicals will contaminate to soil and water system and then find their way to human body. This will lead to the likelihood of development long-term health issues such as respiratory disease or the risky health concern. Fuel tank safety, we should always make sure that our fuel tanks should be safe. There should not be any type of fire or any type of risk or any type of contamination. This I have shown here. You should not hear smoke. Just you see. This is the cartoon which gives some signal or some message that we should take very much precaution, not like this. It is not acceptable. Smoking near the aircraft or smoking with when you are fueling the aircraft. It is very bad practice. The fire triangle, I have just before also I have started that. To approach to a fuel tank safety revolves around preventing the conditions in the fire triangle referred in ED. This, in general, in order for explosion to take place, all three elements are required. So, to take any explosion, we need the fuel, we need the oxidizer, and we need the ignition source, or this is called heat. Okay, this is material, burning material, and this is the oxygen. These three things are required. If you have this thing in a proper quantity, that time fire or explosion will take place. So maintenance program, we have to take some maintenance program for the different type of aircraft. So here we have the Airbus maintenance, 12 years, and different types of maintenance and practices are shown here. Fuel tank wiring, the wiring of the aircraft has to be done very nicely. There should not be any short circuit or any type of things. That we have to make sure that it is done properly. Possible problem areas, what are the different area which gives the problem? That is the insulation of the wire. Not this is the properly, it is not done, so it will create some problem. This wiring harnesses, if they are broken, they will also create. So during maintenance, we have to make sure that these all things are done properly. Tank probes, we are using some tank probes. So there, if any misalignment is there or some electric shortcut is there, this may happen. Bonding problem area, if we do some bonding or this electrical short circuit or your earthing should be properly. Possible problem area, this we can, possible problem area in tanks. Okay, so all anti-corrosion treatment, any type of install AMM and other things, this has to be completed. Ground fault interruptions, so we have to make sure that this all things are done. We have to display the warning when working on the fuel system or fuel system component. We have to make sure that we have to display some warning, like here, that fuel is fueling and defueling in progress. And here I am completing this module 4. Hope it is very useful to all. These are the references: Moir and the Seabridge aircraft systems, and another is the design and development of the aircraft systems. Okay, so here there's I'm thanking you all for this thing, and I will continue for my next lecture. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.